Anisotropic expansion. Anisotropic expansion we are going to discuss related to the expansion in 3-dimensional. If you observe, first let me take one cube here. So if I have taken one cube means that is having 3 dimension. So 3 dimension means x axis, y axis, z axis. All the 3 axes it has. Let me take this blue line indicates x axis and this yellow line indicates y axis, and here this z axis is indicated by the green line. So I have selected one cube, that means cube means it is a 3-dimensional thing. 3-dimensional means it has x coordinate, y coordinate, z coordinate. So here the expansion in all the directions are same, then we call it as isotropic. But anisotropic means when temperature is increased, expansion in different directions is different. Along x axis it is alpha x, along y axis it is alpha y, and along z axis it is alpha z. That means coefficient of linear expansion is not same in all the directions. It is expanding in different directions in different way, then we call it as anisotropic expansion. In most of the solids, atoms are arranged at uniform interatomic distances. Thus expansion takes place uniformly in all directions. But in some solids, interatomic separation, that means the atom distance, interatomic separation is what will happen beta? Interatomic separation, different directions are different. Most of the solids, all the interatomic distance separations in the solids is same in all directions, uniformly distributed. But in some solids, this type of phenomena we can observe, anisotropic expansion. Now how to write the gamma means? Gamma is nothing but now alpha x plus alpha y plus alpha z. Suppose it is isotropic means what you used to write? Isotropic means alpha x is equal to alpha y is equal to alpha z. Let us write it as alpha. Let we call it as alpha. So we used to write gamma is equal to 3 alpha. I hope you are clear beta. So what is happened here? We are discussing about anisotropic solids. Anisotropic means that is expansion along x axis, expansion along z axis, expansion along y axis is not same. That is the reason coefficient of linear expansions are also different along x axis, z axis and y axis. If they are same, we used to call it as isotropic. If they are same, we used to call it as isotropic. But they are not same. So gamma is alpha x plus alpha y plus alpha z. So this is about volume coefficient, effective volume coefficient we can call, and the average value of beta. What is average value of beta? If you take here average value of beta for an isotropic solids. An isotropic solid means I can write it as beta is equal to 2 by 3 alpha x plus alpha y plus alpha z. Why 2 by 3? From where did you get? Because in isotropic, what we discussed in our last class, there we have alpha is to beta is to gamma equal to 1 is to 2 is to 3. There we told that gamma equal to 3 by 2 beta, or beta is also we can write it as, or beta is 2 by 3 gamma. Beta is equal to 2 by 3 gamma. So this is the information what we got from earlier topics. We got this information. Fine. Now what is our conclusion? Beta is equal to 2 by 3 alpha x plus alpha y plus alpha z, because beta is equal to 2 by 3 gamma. We know our gamma value now it is alpha x plus alpha y plus alpha z. What is the gamma value? Alpha x plus alpha y plus alpha z. 3 dimension. Along x axis alpha x, along y axis alpha y, along z axis alpha z. So gamma is alpha x plus alpha y plus alpha z. So now beta and gamma relation, beta equal to 2 by 3 gamma. Now gamma value is alpha x plus alpha y plus alpha z. So average value of beta, we can write like this. Fine. Suppose they are asking us what is average value of alpha. Average value of alpha for an anisotropic solid. So when we have to discuss this one, how to handle beta, we know already, I told you just now, alpha is to beta is to gamma equal to 1 is to 2 is to 3. Fine. From here we can write beta equal to 2 alpha and gamma equal to 3 alpha. This is the relation between alpha, beta and gamma. From that happily we can say this information. So what I notice here, gamma is 3 alpha, that is alpha I can write now gamma by 3, alpha is now what should I write? Gamma by 3. What is gamma? Here already I wrote what is a gamma means, alpha x plus alpha y plus alpha z. So the volume coefficient of expansion can be written as alpha x plus alpha y plus alpha z. So now from that information, now what should I write? Alpha is equal to alpha x plus alpha y plus alpha z by 3. That is the formula I got. So this is the information about anisotropic solids. Remember beta, what do you mean by isotropic and anisotropic means? Isotropic, in all the directions, coefficient of linear expansions are same, we can call it as isotropic. If all the directions coefficient of linear expansions are not same, then we call it as anisotropic. The expansion of body in different directions depends on the lattice structure of the material of the body. Actually, the expansion of a body in different direction depends on lattice structure of material of the body. So almost I told you already, almost all the solids uniform interatomic distance will be there. Because of uniform interatomic distance, we have isotropic condition. And when you are taking that is interatomic distance is not uniform in such type of few solids, we will observe anisotropic expansion. So I hope now you are clear with anisotropic expansion. Mainly here about the gamma value is alpha x plus alpha y plus alpha z, and beta value 2 by 3 of alpha x plus alpha y plus alpha z, and finally alpha value, it is alpha is average value of alpha for an anisotropic solid is alpha x plus alpha y plus alpha z. I hope you are clear with anisotropic solids concept. Anisotropic solids, what is the phenomena is happening inside, you observed.